Hi, everyone, and welcome to the MLOps Live webinar series, where we discuss how to bring data science into real business applications. My name is Sahar, and I'm the VP of Marketing at Iguazio. It's great to have you all back with us for the first MLOps Live session of 2023. Before we introduce today's session, I have an exciting announcement to make. Iguazio was just acquired by McKinsey. This acquisition is not just an incredible validation of the Iguazio technology and the team behind it, but also for the MLOps field in general, which is gaining momentum and traction, as I'm sure you all see. For a company like McKinsey to make such an investment in enterprise AI really says a lot. I'm happy to share that the entire Iguazio team is joining McKinsey and will continue to build the technology and showcase great examples of data science and data engineering at scale in the wild, just like we're going to see here today in a few minutes. We're continuing to serve all of our clients and continuing to work on MLOps as we have been before, and you will see the continuity there. But I won't say any more about the acquisition. This was just a very quick announcement because this session today is really all about Seagate and the incredible work that they're doing. So today, we're delighted to have with us an amazing practitioner and friend, Vamsi Paladugu, Senior Director of Live Cloud Analytics at Seagate. Vamsi and his team have built an incredible solution for advanced manufacturing at scale, which he's going to share with us here today. This works across 7 different factories. I'm not going to give anything away. I'm going to let Vamsi tell the story in a minute. Also with us is Yaron Haviv, co-founder and CTO of Iguazio, to take us through the session today. Vamsi will give us a quick introduction to Seagate and then dive into the challenges that they face specifically around data engineering at scale and how they were able to solve them, enabling high scalability and efficient resource utilization, bridging the gap between data engineering and data science, and creating one production-ready environment with enterprise capabilities for the whole team to work on together. We're going to hold a live Q&A session where you can ask our speakers any questions that you have on these topics. So feel free to write your questions in the Q&A panel at the bottom of your screen during the presentation, and we'll do our best to get to all of them at the end. During the session, we'll also run 2 short polls to hear from you about your MLOps journey. So please do fill those in. These polls help us make these sessions as valuable as possible for you. As always, we'll make sure to share the results at the end. We know that you're all keen to see what everyone thinks about these topics of MLOps. Before we get started, I'd also like to invite you to join over 800 MLOps and data science practitioners in our MLOps Live community on Slack. We'll share the link in the chat in a moment. This way we can continue the conversation after the session, and we'll be happy to answer any additional questions that come up after we speak today. We'll drop the link in the chat box and we invite you to join us. We've now put everyone on mute and we're recording the session so that we can send it to you afterwards. We always get asked if we'll send the session recording after, so definitely you'll receive that via email from us. If you'd like the slides, you can just drop us an email and we'll be happy to send those as well. And with that, I'm happy to pass it over to Vamsi to get us started.
Sure. Thank you. Thank you, Sahar. Hi, everyone. This is Vamsi Paladugu. I'm the Senior Director for Live Cloud Analytics at Seagate. I'll just take a brief moment to introduce Seagate or talk about Seagate. As most of you might be knowing, for data storage, Seagate is the industry leader. We power the storage infrastructure for most of the world's data. Seagate shipped more than 3 zettabytes of data in last 40 years. And we have 40,000 plus skillful global resources, 7 manufacturing sites across the globe equipped with nano precision technology and smart manufacturing. Next slide, Sam. With the leadership in our storage, we have been with the leadership in our storage industry. We were able to leverage our big data and AI technologies across our smart manufacturing capabilities across the 7 factories. Today, our AI-enabled Seagate factories generates 50 terabytes per day across all our sensor, parametric, and image data, which are analyzed and learned by descriptive and predictive algorithms that autonomously autonomously monitor our entire data sphere for use cases like anomaly detection, fault detection, and sophisticated control systems. So we will walk through in today's presentation how some of the challenges we had, both business challenges and technical challenges, on getting this huge volumes of data and deriving insights out of this data. Next slide, please. So one of the key challenges in any of these big data scenarios is the data itself, right? As the volumes of data gets significantly increased coming from IoT data and sensor data, the challenge is the ability to store this data and derive insights out of this data. With the expertise in the data storage, Seagate recently launched Live Cloud, which is a simple, trusted, and efficient cloud storage platform. Live Cloud is a S3 compliant object storage platform designed for frictionless mass capacity storage and predictable economics. This is one of the key components of our big data stack that I'll be walking through in our next slides. Next slide, please, Sarah. To address the complexities of big data processing and analytics, we leveraged Live Cloud Analytics platform, which is a combination of infinitely scalable Live Cloud S3 and fully managed data engineering and automated MLOps solutions powered by our partner Iguazio. This is a unified open data lake platform, which is simple and trusted, with industry-leading open source frameworks for big data processing and serving. Some of the key open source frameworks, which is Apache Spark, which is the industry-leading open source framework, is provided as a complete managed service in this platform. And this is one of the platforms we leverage for all our data processing across all our factories. The other one being Trino, which is a distributed querying engine, high-performance querying engine, which is provided as a managed platform in this environment, is used for most of our querying across our organization.
Maybe we can mention that Trino is essentially what used to be called Presto.
That's right. Yes, that's right. Trino used to be called Presto earlier, and with the split, it is now Presto and Trino, right? Yeah, and Trino is extensively leveraged across the industry for many of the big analytic processing engines. And the second major component that we leveraged in some of our manufacturing practices is automated MLOps provided by this platform. Automated MLOps, which leverages Iguazio's ML Run and serverless Nucleo platform used for deployment, provides end-to-end automation of machine learning processes and provides orchestrators for experiment tracking, artifact governance, and monitoring, ensuring reproducibility and reusability and seamless transition between development and production. As most of you know, a lot of the projects, ML projects specifically, just get stuck at the development stage. How we can seamlessly deploy in production and scale in production is what we achieved with this platform in some of our manufacturing practices, which I'll walk through in the next slides. Next slide, please. So specifically talking about case study for Seagate. So I'll be talking two case studies for Seagate today. One on the big data platform, on how we are able to leverage this platform in ingesting the data from 7 factories solving some of the data challenges we had with the unification, and specifically some of our AI ML projects that helped us improvise our production quality. So this specific use case, we ingest, as we mentioned, around 50 terabytes of data from our 7 factories across the world. So using this platform, we are able to ingest the data either in batch or even in real time, depending on the use cases, into our centralized data lake, which leverages which is leveraged by various organizations across Seagate, one for coherency of the data across the factories, and also to help with the product, improving the product quality, production efficiency, and other use cases.
So maybe you can go into a little more details on like how do you do the ingestion? What kind of tools are used in what scenario?
Absolutely, Aaron. Next slide, please. Next slide, I think we'll cover that in detail. So for the ingestion of the data to our Live Cloud Analytics platform, which again is powered by Live Cloud and Iguazio's analytics stack. So we ingest data using various PubSub tools depending on the scenarios. Some of the scenarios being we use Kafka for our real-time ingestion. We use NiFi and internally built PubSub models for mini and micro batch ingestion of data into this platform. We ingest more than 50 to 60% of our data coming from all these factories, as well as data coming from our customers and suppliers into this enterprise data lake. Earlier, before we had this platform, some of our challenges were even ingesting the data, right? One is ingesting the data. Two is ability to process this data at scale. So now with this platform, that's the advantage we have is now we are able to ingest as much of data as needed for all our analytical purposes. So the Live Cloud Analytics platform that you see here, as we are seeing, we primarily use Spark for all our ETL processing and transformation of our data. So we built certain kind of frameworks and templates as best practices so that, for example, today we are close to processing around 1,500 tables of data in this platform, which includes data from sensors, parametric data, and also image analytics data. And all this we are able to seamlessly scale with many kinds of templates that we build, which some are metadata-driven templates for ETL processing, and some are the templates that can easily scale the orchestration of these processes. We leverage extensive. Sorry, please go ahead, Aaron.
Are those Spark streaming jobs, Spark batch jobs, and how we managed?
Yeah, good question, Aaron. So we have both the processes. One, the primary use cases here, I would say 70 to 80% we use the Spark ETL processing. And we have 20 to 30% of use cases, which are kind of real-time processing scenarios where we use Spark streaming. So that's the combination that we leverage in this particular processing, right? Data gets processed anywhere from few minutes to few hours, depending on the scenarios and depending on the factory that we get the data. For example, our drive factories generates huge volumes of data, which is mainly located in our Thailand and Wuxi factories in China. In this case, the data latency is little high, because even the data consumption can wait for few hours from the data from the time it is generated. But something like a wafer factory, we need the data very much real time for the decision making. In the case of wafer, we do very much the real time streaming of data using some of these newer technologies, which includes Kafka and Spark streaming. And within our data engineering platform here, so we leverage Airflow as our primary orchestration engine to run all our DAGs, and which kind of continuously running as part of this process with the various dependencies embedded in that. We also leverage ML run to trigger some of these, integrate between various processes within this platform.
So Airflow essentially creates a DAG of ML run functions that are Spark jobs that are
Spark jobs that has interdependencies, and the workflows are scheduled accordingly based on that. Right? So we also the advantage of this platform is because whenever we have a data engineering platform or a big data platform like this, the users want what we call open data lake architecture, in the sense that they should be able to build their own ETLs, build their own querying engine so that they can seamlessly consume the data out of this platform. That's the kind of open platform we provided here, where users have the ability to create their own ETL. We provided framework so that the users can easily add on top of this framework and create their own ETL process. That's one of the big advantage we provided in this platform. And that's why our users very much like this platform from that perspective, because they have the freedom to create their own process. At the same time, as a central organization, we govern how the ETL process should be structured so that everybody is in line and leveraging the similar process. From the data, sorry, please go ahead.
How do you handle things like upgrades? So you have a pipeline running, and now you change the logic, the ETL logic, etc. How do you handle those kind of things? Probably complicated, no?
Yes, there is. That's one beauty about this platform, along with Iguazio, as well as there are two kinds of upgrades here. The platform upgrade itself, which includes upgrading the Spark or Trino, that's completely managed within the Iguazio platform itself, in the sense that when the upgrade happens, it's very much seamless to the customer or to the business users. But again, there are always the testing we do in our stage environments, where if there are additional functions or if there is any changes, but otherwise it's pretty much a seamless process of upgrades primarily for Spark and Trino from that perspective. But the second part of that is if you are refactoring our ETL frameworks, and if you're redesigning our ETL frameworks for optimization and some of those things, that's where we do a lot of change management with the consuming power users who has their own ETL. So we need to coordinate with them, and we have a very good data governance process that we coordinate between different teams. And the platform as well helps there, in the sense that how easily the data engineers and data scientists can leverage, then can coexist and leverage and share some of these processes. That's what the platform kind of helps give those capabilities as well. So that's from the data engineering perspective. And as you can see here, the consumption part of it, I mean, there are different kinds of analytics here that runs on top of this platform, which includes the descriptive analytics to predictive analytics. There are various kinds of tools we use, the BI visualization tools like Tableau and GEM, and then various ML solutions that leverages the rich MLOps capabilities of ML Run and the deployment capabilities of Nucleo to easily scale from development to production. That's one of the significant advantages we got with implementing some of these solutions.
And maybe one other question, you have here on the data serving, you have Trino and Spark. Again, Trino is sort of a newer version of what used to be called PrestoDB, which was initiated by Facebook at the time. A very strong distributed SQL processing engine that can work across different types of data stores and databases. But can you highlight, where do you use Trino? Where do you use Spark SQL? What's the advantage of each one of those?
Absolutely, Aaron. So that's a very good question. So, I would say 80% of the cases or 90% of the cases we have been using Trino. Initially, when we started this journey, actually, we started with a completely Spark framework. Over the years, earlier, it used to be MapReduce and Test Down High. When we completely re-architected our solutions to move to Spark, we were leveraging Spark for ETL as well as Spark SQL for most of our queries. But from the performance perspective, Trino kind of, at least in our scenarios, was giving us more than 5x better performance than Spark SQL in many of our scenarios. That's one of the reasons we migrated to Trino in most of the cases. But there are some cons in the Trino which are kind of addressed in the latest versions. But some of the cons are resiliency, in the sense that if you're running your queries in a distributed manner, if one query fails, your queries completely fail, right? Whereas in Spark, you have the advantage that it retries and the next process picks up and your queries can continuously run. So that's the kind of advantage you get with Spark. So wherever we need the critical applications that requires this kind of stability in the queries, we still use Spark SQL, even though it takes a little bit longer time. But whereas the 80% of the cases where we can live with query failures if they fail, but we had now recently implemented a retry mechanism and some of these in the latest versions. That's where we use Trino versus the Spark SQL. But Trino is what very well adopted across the company, and 80 to 90% of our use cases leverage Trino. 10 to 20% leverage Spark SQL.
And that's mainly on top of the S3 object store with Parquet?
Yes, all our use cases leverage, all our data platform leverages S3, like Cloud S3 in this case. Earlier, we used to use AWS S3. So yes, we have both, Aaron. We use ORC and Parquet formats, depending on some of the use cases that we have. Right. So historically, we were using ORC, so that continued with ORC, and some of the use cases that we onboarded recent in the last few years, we moved to Parquet. So we leverage both the formats.
And can you add some details more on the machine learning side that you have on the right side?
Absolutely. So on the machine learning side, on the machine learning side, my team's charter specifically on the machine learning side is we help our data science organizations mainly in accelerating ML. That's kind of our charter. That's exactly fits in with Iguazio's charter of that's when we looked at MLOps acceleration. On the machine learning side, various teams leverages various frameworks. Some use H2O, some use Spark ML. And there are various deep learning projects, which includes which primarily for our image analytics and some of our sampling AMKPIV kind of projects. So what we were being constantly in last 1 year have been slowly migrating them to the kind of architecture that is needed. One is kind of microservices architecture, which again fits into the MLOps frameworks. So that's what we have been working in last 1 year or so, moving to that architecture and embedding into this MLOps frameworks, where we can have this kind of model versions, data versioning, and how we can easily scale and deploy to production. So that's what we have been slowly migrating. We are in the process, and we have at least few projects now, which we are moved into this kind of platform. Next slide, Sahar, please. So until now, we talked about the challenges that we had and how we were able to do with our big data scenarios. And specifically, I want to talk here, I want to take one specific scenario, which is within wafer manufacturing, one specific scenario of smart sampling, and how it really helped us to improvise on our, primarily on our product efficiency, right, and product quality. Some of the key challenges, as you can see here, is basically on basically on the manufacturing time, right? So what happens is most of our 40% of the time is spent on the measurement steps. So our objective is how can we predict the quality of the processes so that we can skip some of these operations and reduce the production time. This significantly helps us reduce our cycle times and capital cost, and as well maintain our product quality. So next slide, please. Some of the challenges with this process is, again, the number of operations and stages have increased 5 times in the last decade. But however, our human and equipment capital have not scaled at that level. So we always continuously keep looking for smart ways of manufacturing. And one of the important way of achieving this is to do what we call smart sampling, which is to reduce the measurement steps, which are obviously the 40% of our manufacturing cycle. Some of the key challenges, again, in this case is the huge volumes of data. You get getting a sample selection on 4 petabytes of data is a massive thing. So how do we address some of these concerns, leveraging huge volumes of data and the complexity of the data structures itself? As and when the stages and operations increase, the complexity of the manufacturing process increase tenfold. So taking all these into considerations and building the systems is some of the challenges we have, which we were able to address with this platform. Next slide, please. So the three components that helped us achieve with the Live Cloud and Iguazio platform. One, again, is understanding our data. So there is a coherent access of data available across our multiple factories that needs to be ingested into these data platforms, where we need that kind of scalable data platforms, how we can scale the data structures, how we can ingest, process, and make the data available for our data science applications. And unraveling the complexities of the ML itself. One, with a lot of these features we have now, we needed some things like automated feature engineering, which helps identify the features and then help them seamlessly transition between different environments, different versions, and also between development and production. This manufacturing process we have like thousands of operations and thousands of steps. So how do we deploy some of these models across all these operational steps is a challenge earlier. Now, with a platform like Iguazio with Nucleo, we are able to seamlessly deploy some of these models in an automated way with this, I would not say single click, but with a single few lines of code across multiple operations, deploy, scale, and get the inference out of these models. This is one of the significant advantage that we are able to get out of this platform. Again, the open source frameworks, which gave us the flexibility we keep moving the data across various factories, and even within the same factories, how can we leverage the framework that we built within one factory? Now we can seamlessly transition to our other factories, which has the similar analytic scenarios. That's one of the key thing that we are able to achieve with this platform.
So one day, I assume you had a solution before building this. This is relatively new platform.
That's right.
Can you quantify the advantage of doing that? Like how much money you saved, what kind of business value you generated, et cetera, by moving to this sort of federated, open source architecture?
Absolutely, Aaron. Yes, we had this kind of solutions. Seagate itself in general has been kind of the leader in the AML space for more than 5-6 years or more, almost a decade, building on some of these solutions. And so we had many of these even like 2-3 years back and even 1 year back, some of these solutions that are deployed. But this solution helped us reduce the technical debt. One is technical debt. How do you not do a lot of it custom versus how do you leverage some of this platform to easily scale and to also easily scale the frameworks across different factories. It helped us, I would say, it helped us reduce. We can't quantify the amount in dollars, but at least in many cases helped us reduce 40% of our cycle times, and at least based on our analysis, at least 6% in our increase in efficiency in the people efficiency immediately in this one factory. Right.
And did you reduce the overall TCO? Did you see?
Yeah, absolutely. Yeah, there is a significant reduction in overall TCO. Sorry, please go ahead.
Yeah, I'm saying, did you see your cloud bill sort of go down, or your?
Yes, yeah. From the cloud bill perspective, yes, definitely. In the sense, we had different layers in this. If you look at the cloud bill, one is the storage cost itself, then the compute, then the analytics cost. Obviously, the advantage you get is one with the live cloud storage. There is a significant cost reduction compared to the hyperscalers that we were leveraging earlier, and same thing with a platform which combines both data engineering and MLOps into one stack, and getting the efficiencies, like I would say at least around 10x to 12x improvement in the processes. We're able to see significant reduction, close to 40% overall is what our, compared to our earlier bills that we had from the hyperscalers. Right.
So you're saying you save significant amount of money, but you're doing a lot more work.
That's right.
Platform. So that at least a 2x saving, if not more than that.
Absolutely, that's right. Yes.
Mhm.
Okay. Next slide, please, Har. So this is the view of how we are able to integrate, one view of how we are able to integrate data between one of the scenarios that we exactly talked about, which is smart sampling, or what we call sensor data that is coming out of our wafer factories, how we continuously ingest the data into the live cloud storage, from where we run both the data engineering process, which includes data ingestion, processing, and how it is seamlessly integrated with our MLOps environment, which includes, again, the model training, model validations and testing, and again, deployment of inference, and how we can integrate it back to our factories. This includes, this platform, because we were leveraging some of our on-prem tools, for example, Gate, or we have our own code version control tools. We were leveraging everything that we were leveraging earlier, but able to integrate into this platform and get that kind of scalability with a continuous loop of process between the data generated in the factory to processing the data, running the ML modeling, and then inferencing and write back or influence back the results to the factory. So this is kind of the end-to-end loop that explains the process that I was talking about in my earlier slides. I think that's all the presentation I had.
Great. Thank you so much, Vamsi. That was really, really interesting. We're just going to pause there quickly to take 2 quick polls. I'll launch them now. And then we'll head straight into the Q&A. All right, so here's the first poll. How are your data science and data engineering practices aligned today? Are they separate teams with a separate tech stack? Are they separate teams working on one unified tech stack? Are they the same team but with separate tech stacks, or same team, same stack, all unified together? And we're heading into our second poll. How do you handle data engineering at scale today? Are you using cloud services, analytics, or big data platforms like Databricks? Are you doing a DIY, Spark over Kubernetes, for example? Are you actively looking for a good solution? I'm sure some of you haven't cracked it quite yet, or maybe you don't have a need at the moment, and that's also fine. All right, so we have some interesting questions here already. The first one is, I guess, for Vamsi. Live cloud analytics seems to be a great fit for MLOps and AI manufacturing use cases, but are there other use cases that this solution could solve for?
Sure. Thank you for the question. So again, live cloud analytics platform is for solutions that requires mass capacity data storage. Any AI ML solutions that requires mass capacity storage and want to derive insights out of the mass capacity storage, live cloud analytics is a perfect platform for that, which can be include any other. It's just not manufacturing, either it's automotive or media or finance or insurance, any other scenarios, it works well.
Excellent. Thanks for that. Another question here, is there a need for the use of GPUs in any of these workflows?
Yes, absolutely. I mean, many of the workflows, for example, in our scenarios that we are talking about, we have many scenarios which is primarily image analytics scenarios, which will leverage GPUs. And again, Iguazio platform provides us that workload-aware scalability even for GPUs, both for CPUs and GPUs, which includes we can scale down, scale up. That's the important part. It doesn't have not just about this platform. Any platform that we leverage today, it's very important that we have that kind of scalability in the compute, either it's regular compute or GPUs.
And that counts just also, so everyone knows, it's also part of the MLRun open source project. It's not just the commercial, there is the concept of scalable runtimes that can have multiple GPUs and distribute them.
That's a great point. The next question is from Akarash. I hope I'm pronouncing that correctly. A graduate student pursuing master's at Santa Clara University. He is wondering, how does live cloud analytics vary or outperform compared to Azure offerings such as Synapse Analytics, for example, or others like Databricks? Can you say a couple words on that?
Sure, absolutely. So again, so at scale, right? So at scale, live cloud is a perfect environment at scale as your storage is growing, right, into petabytes, right? So what happens? One is the cost, and the other is obviously the scalability of the platform. As you're at scale, as it's going to 3 to 10 petabytes and it growing, you see the significant increase in cost, but the compute remains the same. So from those scenarios, live cloud analytics is a perfect environment. And the second one is in Azure or AWS, again, it is multiple tools and there are a lot of frameworks which will also might lock you into the systems. Whereas the solutions that are provided here, one, all of them are open source frameworks, either it is data engineering or the ML solutions. And two, they're all provided as one integrated solutions, which kind of simplifies your end-to-end journey from data engineering to data science. Those are some of the advantages.
Yeah, I think there is another point, and it's mentioned here, Databricks. I think Databricks in general is more of an interactive development platform. You have notebooks, you launch a job, etc. I think what we've seen in your solution, that there's a lot of things that are, really more online, always running, jobs that get schedules, real-time workloads, interactive queries using Trino, which need to respond within milliseconds or seconds. I think it's if you're trying to think about something really operational, like managing factories, it's not simple to build those kind of solutions with Databricks. Would you agree?
Absolutely, absolutely, Aaron. So this is again, this solution is a mix of everything, right? So you have real time, you have batch processing, your schedules running 24/7. Then you have query engines like Trino, which are sub-millisecond, with a millisecond response time. So that's the advantage you get. And yeah, obviously, Databricks is not a end-to-end solution from that perspective.
Yeah, and also other production-related aspects. You mentioned working with Git and CI/CD. Those kind of workflows don't fit well into the ones that sort of you mentioned here, like Synapse and Databricks.
That's right.
Niron, I think there's another question here for you, asking about computer vision in production with live webcams. Reminds me of a couple of customers.
Yeah, I think it's more related.
With.
Yeah, I think it's more related specifically to Seagate and the factories. There are actually some use cases that ones you can mention in the manufacturing that I'm aware of. Obviously, we see that across manufacturing is essentially being able to sample cameras and turn it into frames, and those frames go into training flows and inspecting for different damages in the pictures. But maybe ones that you can mention. I believe you have such use cases.
Yes, absolutely. Yeah, primarily on the images, right? So more than video, a lot of our use cases are around images. All in many of our factories, either in the media factory or in the wafer, in some of the in sliders. So we get images generated from those factories. We have certain sophisticated tools which helps extract these images and we ingest them into our data lakes, on which we have real-time analytics as well, run and infer. We have some AI scenarios like what we call automated defect classification, which compares various images and then gives the output on and predicts which images can be a pass versus fail, and kind of skips those steps. So those kind of scenarios and many other use cases that we leverage.
There is another question here asking if we can say a couple more words about how we do the sampling.
Sure. From the sampling perspective, so there are various scenarios, and especially from our wafer manufacturing perspective, we have different. We use different techniques from that perspective. I mean, which includes either using the light GBM or even on deep learning. Recently, we are also moving towards deep learning, various algorithms for sampling, which includes like between KPIV and KPOV data that is generated, and how do we correlate between KPIV and KPOV and on that generate that kind of sampling percentage by correlation mainly, right, between KPIV and KP. Those are some of the things that we do.
Excellent. A question here about data privacy. Is the cloud platform GDPR and other data privacy compliant?
That's right. Yes, Live Cloud is a completely SOC 2 and GDPR compliant solution, right? So any data that is stored type 2, SOC 2, that's our primary, and it's completely certified, ISO certified compliant storage.
And can you say a couple words about the underlying data infrastructure of Live Cloud? Sorry, the data structure of Live Cloud. NFS, GPFS, S3 combination.
It's all object storage. It's completely Live Cloud is S3 compliant object storage. It's completely all S3 API compliant. Right? It's a S3 object storage.
Yeah, and maybe to add here a couple of points. First, there are some challenges initially with sort of Spark and even Trino around how to work with object store. Those things I remember were sorted out in the early days, or older versions of Spark weren't, all the things about logging and commits and so on. You can probably mention a few words on that.
Sure.
But I think in general, using object store provided huge scalability and performance. And I think the other nice thing about it is by leveraging the same kind of format and Hive schemas and Parquet files, etc., you can use different engines. On one end, you could read it with Pandas. On the other end, you write it with Spark. You could read it with Presto. So then it gives you sort of a unified store for multiple engines to go read and write the data from.
And that's it. That's very well said, Yaran. Yes, that's right. Yes, and from the eventual consistency perspective, earlier in the initial days, there are challenges with what you call the eventual consistency between read and write. But now all of those are addressed in the latest versions through Spark using some magic committers, some kind of committers, so you don't have those kind of issues. And now with even the ACID transactions, leveraging the open source stable formats like Iceberg, which we recently started moving towards Iceberg or leveraging Iceberg. So even now our Hoodie as well, from that perspective, Iceberg or Hoodie, even the ACID transactions are now supported on object storage, which equals to your any RDBMS solutions that you might have.
Nice.
Nancy, we have a follow-up question on the sampling topic. It's very interesting.
Sure.
What was that sampling method acronym? KP something.
KPIV data. So the KPIV data, the KPIV is the input variable data, right? And then the KPOV is the output variable. So a lot of the sampling algorithms are correlation between KPIV and KPOV data, right? So that's
excellent. Thank you. Final question. We've been using public cloud services for a while, but the cost was really difficult to manage. Can you talk a little bit more about how the solution saves costs? You and your own spoke about it a little bit, but maybe you can elaborate for the forum here.
Absolutely. So again, there are multiple components in the cost, right? So when you leverage public clouds, one coming to the storage, even on the storage, you have egress cost, you have API charges. So one thing that this platform provides is no egress, no API cost. It's just the cost of the storage that you do, which is also significantly less than the premier clouds. And the second, coming to the analytics platforms itself. So again, this is one solution with the data engineering and MLOps kind of combined one solution with one cost compared to any of the providers. You have multiple, like you have even within data engineering, you have multiple tools. And then multiple pricing, and even within MLOps or ML, you have multiple products, which gives different kinds of pricing, which is one, it's confusing to manage that many components and the pricing of it, and the cost significantly increases by adding every component. Whereas here, it's a very simple one product with data engineering and MLOps integrated into one product with one pricing.
Maybe another thing to add is that most cloud provider solutions are based on virtual machines as the unit of work. Yes. While here, because it's Kubernetes, the unit of work is containers. So you can actually drive a lot more computation on the same amount of resources. It's a lot more optimal, higher and higher efficient.
Absolutely.
And I think cost efficiency is something that is of utmost importance, especially in today's economic times for most companies. So that's really interesting to hear.
Yes.
We will take one last question because it's a really great one. What sort of latency demands is seen for real-time inference?
So from the real-time inferencing perspective, I mean, there are a few things on the real-time inference, right? So any solution that we look at for the real-time inferencing, the latency should be less than 2 milliseconds or even less, right? So that's how we measure, and some of the solutions we deployed, even on live cloud, we look at direct connect with the less than 2 milliseconds of latency. But the main thing again is for the real-time inferencing, the key is the bandwidth as well, right? So that is something to be taken care from the real-time inferencing. One, latency, two, bandwidth, and if you're using the real-time inferencing for factory control systems, which are critical to the factory, we need to make sure the 100% or 99.99% availability on both network, storage, and compute.
Absolutely. Thank you for that. We are near the end of our time, so I do want to just share the poll results as promised. Let me jump right into that. So let's look at the first poll here. The first one was, how do you handle data engineering at scale today? So 32% of you use cloud services. 23% use analytics or big data platforms like Databricks. 23% don't have a need at the moment, which is interesting. But I'm glad you're listening in because that need might arise soon. 16% are actively looking for a good solution, and only 6% are doing DIY. Yaron, that's probably surprising to you, isn't it? We always have a DIY discussion.
No, I think people understand it's really complicated to do it yourself, and you need someone to hold your hand and provide a more managed solution, as people chose here.
That's a great point. That's very true. Let's look at the results of the second poll. Okay, and this was about the alignment between the data science and data engineering practices. So 31% of you have separate teams with a separate tech stack, a very silo type of approach. 31% have a very unified approach, the other side of that spectrum, same team, same tech stack. And 19% are in the middle. So either separate teams, separate tech stack at 19%, and 19% with the same team and separate tech stack, which is really interesting. So it's really kind of polarized on the two ends of the spectrum.
I assume it also depends on the scale. A small organization will probably have everything unified, and a very large organization will probably have more siloed.
That's a great point. Yeah, definitely possible.
Yeah, so anyway, I would like to really thank Wamsi. It's not every day that we get in MLOps Live a practitioner with a lot of experience, hands-on experience that sort of build things at such a huge scale. So I'm really happy that he could make it and share his insights.
Sure, thank you.
Absolutely, and I second that. Thank you so much, Vamsi. Before we sign off, I did just want to mention that we have plenty of additional MLOps resources for all of you. You can read blogs, you can see previous sessions of the MLOps Live webinar series. All the recordings are available online. We have other videos with practitioners discussing real use cases, and we invite you to visit iguazio.com/MLOps to take a look at all these additional resources and continue on your MLOps journey. And again, just echoing what Yaron just said, thank you so much, Vamsi, for joining us today and sharing your use case with us. And we invite you all to join the community, the MLOps Live community on Slack. Ask us any additional questions you might have and continue the conversation over there.
Thank you. Thank you so much.
Thank you, Vamsi, and thank you, Yaron, for being with us.
Sure.